until this point, you've learned how to convert between moles and molecules, or moles and atoms, moles and formula units. That's using Avogadro's number. And you've also learned how to convert between moles and grams and mass using the molar mass. So, what you now can be able to do is convert between each of these concepts. For example, you could go from mass all the way to particles instead of just stopping at moles. Okay, so just as a review, the relationship between mole and mass, in order to convert between moles and mass, or mass and moles, you need to use the molar mass. Between moles and particles, you use Avogadro's number, the 6.022 times 10 to the 23rd. The last concept that you might be asked to use is the relationship between moles and volume. Well, if you have a gas and it is at standard temperature and pressure, we call that STP. That's a very specific temperature and a very specific pressure, okay? Then the volume of any gas is going to be the same. The volume of 1 mole of gas is going to be the same. It's going to be 22.4 liters, no matter what the identity of the gas is. So now, as you can see, I've got this awesome tool that allows me to relate between all of these different units of measurement. So for example, if I want to go from volume to mass, what I'm going to do is I'm going to go from liters, volume, first to moles, go to the center, using my 22.4. Then I can go from moles into mass by using my molar mass. Or let's say I want to go from mass to particles. I would go from mass to moles using my molar mass, and then I would do another crisscross swish and go from moles to particles using Avogadro's number. So let's look at an example. This question asks me how many atoms are in 30 grams of aluminum. And so what I'm going to be doing is I'm going to be going from grams all the way to atoms. Okay, so I'm first going to put my given, which is 30 grams. Then I'm going to convert. And first, I've got to get into moles, into my center. So I'm going to put grams on bottom, and I'm going to put moles on top. I'm going to do another crisscross swish without waiting, and I'm going to put moles on bottom, and this time I'm going to get into atoms. Now, to go from grams to moles or moles to grams, I have to use my molar mass. Well, the molar mass of aluminum, I know, so I can plug that in for grams. So for every 1 mole, I have 26.98 grams. For atoms and moles, that relationship is Avogadro's number. So I'm going to put 6.022 times 10 to the 23rd atoms over 1 mole. And so now what I have to do, the last step I have to do is I have to actually figure out the math and figure out how many atoms there are. So I'm going to take 30, I'm going to divide it by 26.98, and then I'm going to multiply by Avogadro's number. And what I get, rounding to 2 significant figures, is 6.7 times 10 to the 23rd atoms. And that's it. So notice for these problems, the only quirky thing is that it might require more than 1 step. It might require 2 steps. But the main thing for you to know is that you are going to first get into moles, because then you can relate anything to moles. Moles are your universal unit, as I like to say.
So let's look at one more problem. So here it says, how many molecules are in 200 liters of carbon dioxide at STP? So I'm going to write out my plan of action. So looking at my wheel, I know I need to go from volume, which is 200 liters. I first need to go to moles, because the mole is my central unit, and then I'm going to go into molecules. So let's actually set up the stoichiometry for that. So I have 200.0 liters. I'm going to get out of liters by putting liters on bottom, moles up top. Now I'm in moles, awesome, but I don't want to be in moles, I want to get into molecules. So I'm going to put moles on bottom and molecules up top. All right, let's plug in my values now. So because this stated that I was at STP, which is standard temperature and pressure, I know that 1 mole of a gas, no matter what gas it is going to have a volume of 22.4 liters. That's one of our conversion factors. So I'm going to put 1 here and 22.4 here. Next, I know Avogadro's number, which tells me that 1 mole equals 6.022, or 6.02 is fine as well, times 10 to the 23rd, either molecules, if you're dealing with an ionic compound, formula units, or atoms. In this case, I'm dealing with molecules, so 1 mole is 6.022 times 10 to the 23rd molecules. So what I'm going to do in my calculator is I'm going to take 200.0, divide by 22.4, and then multiply by 6.022 times 10 to the 23rd. And what I end up getting, unrounded, is 5.37679 times 10 to the 24th molecules. All right, now really quickly, this has a total of 1, 2, 3, 4 significant figures, which means I want 1, 2, 3, 4 significant figures. This is an exact value, so I'm not going to count this for sig figs, and so is this. So I'm just going to be using my given. Now I need to look at the next digit, see if that'll affect 6. It actually will in this case. So you've got 5.377. Don't forget the times 10 to the 24th, because that totally changes the number. And you've got molecules. And so that is your final answer.